here we want to simplify radicals with variables. How do we simplify radicals with variables? Well, the nice thing is, even though they look scary because they're variables, it's actually easier than numbers. Because numbers, you have to think what times what equals to that or divide. You're dealing with all these number crunching in your head, right? There's absolutely no number crunching when it comes to variables. So I kind of like variables better, even though initially they seem scarier. So if we use the same method of the waterfall or whatnot, or rewriting it where it looks like it's a game. So here, the square root of x to the fourth, if I was to rewrite this, x to the fourth is the same thing as writing x times x times x times x, right? So we don't really have to do the whole factoring waterfall because there's no numbers to really think about. You just think there's 4 x's, right? So here, the rule of this game, the index is what? 2, right? So therefore, we pull out what? Pairs, right? So the pairs go out. So when the pairs go out, bam, bam, the pairs of x's goes out, it becomes a singular x, right? It just becomes a singular x. And this x and x pulls out and becomes singular x. So therefore, your answer is x times x. When it pulls out, you just get x squared. Right? I'm going to revisit this problem in a little bit, but then the answer would be x squared. Now, if it's an odd number, right? So here in this problem, how many x's do we have? 3. 1, 2, 3. And the rule of the game is the power of anything to the index of 2. So the pair of x's gets pulled out. So therefore, what stays in the inside? X stays in the inside. And what goes outside? X. So you have x root x, right? So here, it's kind of nice because you don't have to think of numbers, right? You just think the pair, or if it's a cube, and you have to take out 3 of them. If it's 4 of them, it's this or that. Let me throw in another problem. So if I had to the third root of x to the fourth, right? So same problem as this, but it's to the third root. Again, you have 1, 2, 3, 4, 4 of them. How many of them are supposed to be pulled out? 3, right? So in this game, you want, the index is 3, so 3 of them gets pulled out, right? 3 of them that are the same, 3 of a kind, right? If you think of card games, 3 of a kind gets pulled out, and if it gets pulled out, it just becomes a x. So my final answer here is just x, and then don't forget that there's a index of 3, and what's left inside the house? Just an x. So it's the same story, but you have to be very careful of what the index is. The index will tell you how many pairs or 3 of a kind or 4 of a kind that you pull out. Now, what if it was x to 100? Do you think I want to write down 100 of them? I hope not, right? So there has to be an easier way of doing this without having to write it all out and then find the pairs and pull it out, right? So notice, what's an easier way of doing this without having to write all of them out? Divide. If this is 4, right, I know that every pair gets pulled out, so I could divide by the index 2, because the 2 tells you every pair gets pulled out. So if you divide it, you could just pull it out. So here, instead of saying x times blah, 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 100 times, right, and then pulling it out, how many pairs of x's are there? 50. If there's 100 total, how many pairs are there? 50. So one way of thinking about it is doing this. You write it out as x, and you take the 100. Here's the index of 2. You divide it by 2, and therefore you get x to what power? 50. So this, my friends, is actually leads you to a rule or a relationship between radicals and exponents. So remember at the beginning of class, I mentioned that radicals and exponents are brother, sister, right? They're related to each other. You can convert one thing to another. This is a thing that you guys want to remember. If you have x or y, w, whatever, to whatever power. If you take the nth root of it, okay, so this is the index, right? The nth root, you can rewrite it to its sister form. So this is radical form. If you could write it to its sister form, exponential form, simply by just keeping it x to the m, but the index n, you write it as a little fraction on the bottom. So similarly, with this one here, without having to do all this stuff, you could have written it as an exponential, where you write this x, and what does the fraction up here become? 4 divided by 2, which gives you x squared, right? So if you just did it this way, using this relationship here, x to the 100th power, take the square root of it, 100 divided by 2 is just x to the 50th, which means that there were 50 pairs, right? 50 pairs are going to pull it out. So, but what happens if you have an odd number, right? What happens if you have an odd number? What happens if you have an odd number? So here, if you have an odd number, if you want to use this fancy rule here, well, one, you can write it out 17 times. If you write it out 17 times, and then you find out the pairs, you pull it out, and then whatever's left over, you keep it inside. But here, you can rewrite this. First, rewrite it, because you notice that the rule is it's a square root, right? I can't divide 17 divided by 2, right? If I can't do 17 over 2, that's going to be yucky, right? You can't, that's a yucky face. It's not going to be a whole number. You want it to be something where you can divide it and you get a nice whole number. What's a number less than 17 that's divisible by 2? 16, right? So I could rewrite this as x to the 16 times x to the first power. But there's 16 of them, and then there's one left over, right? To make 17. So I could rewrite it in the form that you want it to be. There's 16 x's and then one extra x, which will give you 17 x's. Now that I have in this form, I can use that rule right here to change this part, at least, to be something nice and easy. Can I do 16 divided by 2?
8.
I sure can. 8, because there's 8 pairs of x's in 16, right? So I pull this out, and this becomes x to the 8, because 16 divided by 2 is 8. But the leftover stays inside. The leftover is just x. Same story with this one. So notice this one we kind of wrote it all out. But if I didn't want to write it all out, here's the square root. What's a number less than 3 that's divisible by 2? 2, right? So I can write this as x squared times x, right? Because x squared times x, that's 3 x's, right? X cubed. Well, 2 divided by 2 gives me 1. So therefore, I get x to the first power outside, and inside I just have this leftover x. So again, you can think of it as writing it all out and figuring out how to get the answer, or you could use the relationship between a radical and exponent to solve this problem.